Okay guys, welcome back to part 3. Glad you're back with us on the Philco Holiday Predicta. Just wanted to give you a quick catch up of the work that I've done since the end of part 2. First and foremost, I took the old Sprague Atom 140 microfarad at 300 volt filter cap out of this location here. And I think I made a mistake. In part 2 I stated that this cap should be 140 at 300. Mainly that's because I was going off of what was in there. And again, another good reason to check your schematic, because it does require a 150 at 300. Now the 140 microfarad cap would have worked just fine, and I could have come back in with that, but I did have a 150 cap. And as you can see, what I said I was going to do the last time was, that's a paper towel roll. It happens to fit in nicely in this clamp, and I just cut it off. And then of course I just wired, I don't know if you can see up in there, but just that small electrolytic, wired it in right here, and shrink wrapped it. And then I don't know if you're going to be able to see it over here, but yeah, you can see I just hot glued it and put the cap in there. And of course I put that on there just so if anybody ever gets into this set again, they'll know that that's what that cap is. I also did some work on the filament dropping resistors. Okay, I still have one more to put in here. It's on order. I don't have that yet, but I've got that buttoned up except for those two. And then the last time, on the last video, I was talking about this thermistor situation, and I just decided to go ahead and go with a new 220 ohm cold start one that I had, and the main reason was the old thermistor just basically fell apart when I touched it once. So glad I decided to go ahead and change it. I'm not really sure what I was thinking. I do like to try to keep sets as original as possible, but on a component like that that's that important, I got to thinking, yeah, I better just go ahead and be better off with a new one. And that one measures actually at about 300 ohms cold, so it's really not at the spec that they said it was. So it's closer to that 400 ohms at cold start, so that should work just fine. And of course I cleaned up all these old dirty pins that we had a lot of flux on. I think this one here was one I showed you last time. It was completely touching each other. So, and now what I'm getting ready to do is attack this can here. If you recall, this lead is broken, and the good news is I was able to salvage this can out of my donor set, and I'll be able to use this can, as these leads appear to be okay. Just need to stuff these 4 caps into this can. And of course I've got a handy little wiring diagram right here that tells me exactly where wires should go back into this. And then I'm going to attack this 3-section electrolytic and restuff it, and then the electrolytics will be done. So just waiting on a couple more parts, getting the electrolytics changed, and we should be about done with the underside of this chassis and move on to the top side. I'll get back with you when I get these electrolytics changed. Okay, so this is not another restuffing cap segment. That's a little bit boring to do, but I did want to show you guys on these two electrolytic cans. First of all, I put them on the tester just for kicks, and they both tested really well, all sections. And then this is the most unusual thing. I don't know if you can see that or not. There's liquid. Both of these caps still had liquid in them, and the internals are still very damp and wet. In fact, it'll come off on my finger. That's the first time I've ever busted open a cap of this vintage, and you know, it is really damp in there, and no wonder they tested well. I think these caps would have been suitable to use in the set. Of course, now it'll be better to put brand new caps in that I know are going to last 20 years. But anyway, I was just amazed by that. These appear to be in really, really good shape. And this came out of a Roach set. It had rust on the contacts. I had to put some rust remover on there. I mean, from the outside, you would have never thought this can was in as good a shape as it is. Oh well, just thought I'd show that to you real quick. On with the restuffing. Okay guys, got all the electrolytics caps changed, and moving my attention to getting this on-off volume and contrast pot changed. And it's basically held on by a little clip here, which just pops right off, a little C-clip kind of a deal, and then some 1/4-inch screws, and I'll be able to pop this pot out and get a look at it. Together there. Yeah, they even clipped off the old on-off leads there. I was gonna just check to make sure that these were in fact bad. We'll see here. I mean, I'm sure it's bad. Why would they have rerouted it if it didn't work? But it doesn't hurt to check it. Get my meter to work here. There we go. Okay, that's interesting. When I hold the switch in, I've got continuity, but when I let it out, I don't. So I don't know, I might be able to work on that. And the other thing I just noticed is these are two different part numbers. So I never have been able to locate the run number on this chassis, but it must be after run 6, because this is the pot that has the different resistance. I think it was for the contrast control from 1 meg to 2 meg. So I'm not quite sure if that's going to be a problem or not. I'll have to take a look at that and see if there's anything I need to do to, I might have to, well, I'm just going to have to try to figure that out. This looks pretty straightforward here as to how to attach it. I need to get some reference photos of that. And I don't know, we'll see if that makes a difference. Obviously I'll keep this pot and try to clean this. This back part here is the actual on-off part, and yeah, I'll have to pull the back end off of this and see if I can do some surgery and clean it and reuse this if possible. I know this one works really well. It looks like somebody had clipped off the leads. And I'm sure I could fabricate something there if I needed to, just solder onto these nub points. And let's see, I need to take these off as well, because I also want to make sure I take off this tube shield on the IF strip and work on, take a look at that board under there and do some cleaning. So in order to do that, I really need to remove this board so that I can get to these screws here and complete the disassembly of that. But anyway, I'm going to go ahead and get some lubricant on here. These are just wire wrap, just like everything else on the circuit board, and I should be able to just pry those loose. So I'll get that changed out, and then we'll take a look at the circuit board. Okay, I got the new pot on-off switch, contrast volume control, wired back in, or wired in, and we'll do a test here on diode mode, and the meter should scream. And it is. And that's off, on, off. So that's working good. And then I cleaned up all the other controls, and they look really, really good, nice and shiny, new looking. And I did have someone ask me what I use to clean controls with, and primarily what I use is Deoxit D5. I think you can get this at Walmart, maybe even auto supply stores. I use this quite a bit. It's a great cleaner, and it does have a little bit of lubricant in it. I think it's the best. You can take that opinion for what it's worth. There are a few other products that I use. I use this QD electronic cleaner. If I don't think I need any kind of lubrication in the application, then I'll use this. It works pretty good. Good for just normal contact cleaning. And then Radio Shack makes a product that contains lubricant. I don't like this as well as I do Deoxit, because I think it's got more lubricant in it than is really needed. And then of course Radio Shack makes a precision electronics cleaner that's very similar to that QD. So I use a combination of all those different kinds of cleaners, but the one that I use the most is Deoxit. Okay, so I've gone ahead and removed the IF strip shield, and it did contain a little bit of rust in this area here, so used a little bit of navel jelly and then came back with some 600 grit metal sandpaper and sanded it off, and it looks pretty good. Okay, and then did some cleanup on the circuit board, and for that I use a lot of Q-tips, and I'll either use alcohol, or another product that I use is this Mean Green. Okay, and I like this stuff because it's biodegradable, and it does a really, really good job. Using that just with some Q-tips will get your circuit boards really, really clean. The other thing I use it for is for cleaning knobs. can see here that I've soaked these knobs overnight, and some of this this green product, and I usually just take an old toothbrush and scrub on them and then let them soak. And this is the fine tuning control for the Predicta, and it looks brand new. So, and again, I really like this product because it's not harsh at all. You can stick your hands in it. You can pour it out on the ground when you're done. It's completely biodegradable and safe. So, a great product. And then the work on this board is basically done. I checked most of the resistors. Well, I checked all the resistors in here, and most of them are right on spec. And the ones that have drifted have only slightly drifted. So, you know, I think as opposed to taking this board completely off, I'm going to just leave it the way it is. There are no paper or wax caps on here at all, just ceramic disc caps. So this board should be okay. So I've moved on to starting to remove the wires from the main circuit board, and I'm not quite done with that yet, but one little trick I want to show you that I do is and let it soak for a little bit, and what that does is puts a little bit of lubricant on there so that I can come back in with needle nose pliers and I can pry these off a lot easier. So it takes two hands to do it, so I can't demonstrate, but that's how I do it, and it makes the wires come off real nice. And I don't have to do a lot of solder work, but there are a few that are soldered on, like that one there. There's 3 or 4 around the board that are soldered on that I'll have to desolder, and that's okay because you've got to take all these lugs off anyway in order to get the board out. And I also want to show you that I was messing with this 2-pin socket here. It's supposed to look like that. Now it looks like that because it just crumbled. So having all these new 2-pin sockets installed in this board will be a good thing. But I'm going to keep working. We'll have this board pulled, and we'll pull the rest of the chassis aside and start working on this board. Okay, now guys, I've got the PCB board pulled from the chassis of the Predicta, and now you can see the real reason why everyone complains about working on these sets. There's a lot of wires that are involved in pulling the board, as well as a couple of resistors there and one capacitor there that's connected to the chassis. But you can see here why it's virtually impossible to service the board from underneath, and so really the only way to get at it is to completely remove it. That's not uncommon to late 50s TVs. I know I ran into that on a Sylvania set that I restored last year, and last fall I restored a 14-inch RCA that basically had the same problem. So it wasn't confined just to Philco. They weren't the only ones that designed it this way, but this one certainly is very challenging to work on, just in the fact of what's on this board and how this board's attached. Okay, you might note that I don't have any identifiers on these leads, and the reason for that is I have a donor chassis that is still connected, and it'll show me exactly how to put this back together. So it's not because I have a photographic memory, it's that I've got a nice little example to go by when it comes time to put this board back on. And speaking of the board, here's a little look at it. I've already replaced a couple of capacitors on here, a couple of resistors, And then I've also replaced that broken tube socket with one of the new ones that that I bought. So this board's in pretty good shape. The traces aren't in bad shape, and doesn't look like there's too much scorching. Solder joints look pretty good, but yeah, I have a lot to do. My first challenge will be to replace all the capacitors. I'll probably end up placing most of the resistors, and then, like I told you earlier, I'm going to replace all of the tube sockets, just to make sure that I've got good tube sockets, and that that takes a little bit of time to do, and I'll probably demonstrate how I do that on one of them, and then it'll be on to the K networks. There's 1, 2, 3, 4, 5 on this board, and more than likely I'll end up rebuilding all of those, and that will probably be an entire video just dedicated to that. But first and foremost, it's basic capacitor change, resistor change, and once I get that done, I'll make sure I get all those tube sockets, and then we'll have to deal with the little K network boards. And that's the other part of Predicta restoration. Almost in all cases, I think it's this one that's a vertical integrator, they're almost always bad. So yeah, I'm going to just go ahead and change all those out. And that's the other piece of Predicta restoration that is challenging. So anyway, that's what I'm working on, and yeah, this video is getting a little long, so I'm going to be working on that, and I'll catch you in the next video, and hopefully we'll have all the capacitors and resistors changed, and we can start dealing with those K networks. But until then, thanks for watching, guys. Catch you on the next episode.